Hello, everyone. Okay, this is a new lecture now. In this lecture, I'll be covering section 2.3 and 2.4. So this lecture, I will include this lecture for exam 2. So this lecture is not going to be covered for exam 1. All right, so this is not part of the exam 1. This is going to be part of exam 2. Okay, so like I said, once again, exam 1 is this Thursday, which will be over chapter 1, and also uh, from chapter 2, I'll take 2.1 and 2.2. So that's on Thursday, this coming Thursday. We'll see the exam at 5:30 p.m. You'll get 1 hour 45 minutes. So that means the due will be exactly 7:15 p.m. Exactly. All right. So if there is any problem with the Blackboard, email me your exam. You can email me your exam, but you have to email me before this time. All right. So if you have any internet issue or anything like that, fix it before that. Or you can just do it in the school, or if you live close to school. So yeah, but uh, I should see your exam in the Blackboard or in the email by this time. Okay, that's a fixed due date. I'm not going to do because this is exam. All right, so the exam is going to be pretty strict. All right, so you won't get any extension for the exam. It's not homework, it's not a quiz or anything like that. All right, so yeah, please be serious about the due time. All right. I saw a few emails asking where you're going to see the exam or how you're going to upload the exam. Basically, it's just like the quiz, or basically it's just like the regular exam that you would take in the regular class. It's everything online, right? Like I said, it's everything online. So how you're going to see the exam is, uh, so like I said, probably you can see this tab here, right? So exams. So if you click there, I have already created a tab, but now you cannot see anything. But you will see the exam at 5:30 p.m. Okay, and you'll see the exam. You will see the PDF file here. All right, so open that PDF file. You will see the exam. If you want to print that exam, and if you want to write on that exam, that's fine. Or if you want to write your answer on uh, different paper, different sheet of paper, that's fine. As long as you show me your work. All right. So you have to show your work as long as you show me your work uh, in a numerical order. Uh, that's okay. But you have to upload your work, or you have to upload your PDF file format. That's why I made, if you remember, I made a sample quiz where you were required to upload a PDF file, right? So you need to upload a PDF file, all right? In case if I don't see your exam for whatever reason, or if you upload a PDF file, then definitely I'll see your exam. But if you upload some other file format, then there is a good chances of me not being able to see your exam. So in that case, you will just get 0. All right, so that's why I'm saying please do a PDF file, uh, just to be in a safe side. All right, so once you see the exam, just upload your exam here, right? Just like you do for the quiz. Um, Pretty straightforward, right? So I don't think there is any tricky thing here. Okay, so let's get back to uh, this. And also, I've emailed you guys. Email you guys the exam review, right? I've emailed you guys a few days ago, I think Friday or something like that, Thursday or Friday. But it's still, well, if you haven't seen the exam review, it's here inside the information tab. All right, so I've created a tab here, and there is a PDF file here. So if you just click there, you will see the exam 1 review. All right, so please do these problems because the time you get is just 1 hour 45 minutes. So and also you cannot use any outside resources, or you cannot collaborate with any other students. It has to be your individual work. If I see that some of you guys have similar answer, uh, okay, let me write here, no collaboration. No internet or anything like that. No internet or basically outside resources. You cannot use any outside resources. Just be clear on that. In case if I see that some of you guys have similar answer, of course you're gonna have a similar answer, but the way I can see whether you are collaborating it or not is if you have a similar mistakes. All right, and also I can figure out if you have a similar answer. I can see that, you know, I can see that if you have a similar answer, if you're collaborating with each others, then I can definitely see that. Okay, so in that case, you guys are going to be in trouble. So please be serious about this. All right, and please don't use any outside resources because I can easily figure that out because I also have internet, so I can see that in the internet if you just copy it from the internet. So be very serious about this. All right, so enough talking about this. Now uh, let's go to this actual lecture part. So, okay, like I said, I'll be covering section 2.3 and 2.4. So first, let's start with section 2.3. So 2.3 is about differentiation formula, or basically differentiation. Basically, it also means derivative. All right, so derivative formula. So if you go back to section 2.1 or 2.2 here, so there you learn this this equation, right? You can take the derivative. If this is given, you can take the derivative of f of x, or you can take the derivative of y using this, and this is called the definition of derivative, right? So this equation is the definition. All right, now we are actually going to learn a formula, or basically we're going to learn a shortcut method of finding the derivative of some of the equations. All right, so let's start with the power rule. So the power rule says that okay, let's say if we have y is equals to x to the power n, or basically we could have even say f of x is equals to y. All right, now taking the derivative, so here x is the variable, will be the variable, and n on the top will be a number. There will be some number. So in this case, if you are taking the derivative, so the derivative we can write y something on the power like 1. So this means y prime. It's not y to the power 1. It's y prime. All right. So y prime means a derivative. So in this case, when you're using the power rule of this, well, when you take the derivative of this, the idea is bring this n down here. So n and then x to the power. Now on the power, we'll get some new number that will be whatever the n is, n minus 1. All right, or like I said, there are different ways of writing derivative, right? You can write y prime, or you can write f prime of x, or we can also, sorry, we could even write, since we have y, so we can even say dy over dx. So basically, again, this means we are taking the derivative of y over in terms of x, because we have x here. All right, so that's the idea. So we could have even write dy over dx, like this is equals to n times x to the power n minus 1, right? So now let's see an examples. So the example here, let's say we have y is equals to x squared. Let's start with the simple one. All right, so now if you're taking the derivative of this, it's going to be y prime. Now using the power rule, we bring this 2 down here. So 2 times x to the power, the new power will be x to the power 2 minus 1, right? N minus 1, well, n is 2, so that's why 2 minus 1. So this will give 2 times x to the power 1, or just 2x. Or we could have even say, instead of writing this, we could have even say, instead of saying this, we could have even say here dy over dx. Basically, these are different ways of writing derivative, right? So dy over dx is equal to 2x, right? We could have even said that. It's just the different ways of writing derivative. But you don't have to write both. If you just write this, you don't have to write this. I'm just showing that, okay, in case if you see something like this, this means a derivative. Okay, similarly, let's say y is equals to 3x to the power 3. Then, so here, this 3 is multiplied with this x to the power 3. So in this case, what we can do with this 3 is, we don't have, because this is just a number. So if you have just a number, we don't really have to worry about that, and this number is multiplied with this. So just write this 3, and then just take the derivative of this x to the power 3. All right, so when you take the derivative of x to the power 3, again, we can use the power rule. So I can bring this 3 down here. So 3 times x to the power 3 minus 1, right? So I'm just using the power rule. So this will give 9 times x to the power 2, or x squared, or 9x squared. Okay, so this is how we can use the power rule. Okay, now the next one, the next rule is, let's say we have y is equals to 2, just a number. And then now we need to find the derivative of this, just a number. Okay, so when you're taking the derivative of just a number, then it is always 0. Okay, if there is a variable attached with this, like this, then it will be this condition. So in that case, you'll do this. But if there is just a number, then it is just 0. Okay. There could be any number, doesn't matter, if as long as there is a constant. The constant means just a number, right? So as long as we have a constant, and when you take the derivative of a constant, it's always 0. Now y is equals to x. All right, so when you're taking the derivative of y is equals to x, or when you're taking the derivative of y, or we can even write dy over dx, right? Is equals to, here we're taking the derivative of this, so we could say dx over dx. Okay, so this means dx over dx is just 1. All right, another one, what happens when we take the derivative of an exponential function, but e to the power x, right? So e to the power x is an exponential function, right? So when we take the derivative of this, then it's simply, well, just same thing. When you take the derivative of exponential function like this, e to the power x, then it will still be e to the power x. Nothing changed. All right. Okay, now let's do some examples. Let me do that here so that I can show you everything on a single page. Okay, let's do a first example. Let's say we have y is equals to y is equals to y is equals to 2x to the power 3 plus 3x plus 7. Now we are taking the derivative of this, so we can write y prime is equals to, okay, now here this 2 is attached with this x to the power 3, and these two are multiplied. So like I did here, I can just simply write 2 here again, and then just take the derivative of x to the power 3, right? So in that case, using the power rule, I can bring this 3 down here, and the new power we get is 3 to the power x to the power 3 minus 1, right? Plus again, this 3 is attached with this x. So in this case, again, 3 will stay there. And when you take the derivative of x, this is simply 1. So just 1. Plus the derivative of 7, which is just a number. So when you take the derivative of just the constant or just the number, it's 0, right? So it's 0. So that means the derivative here we get is 6. 3 times 2 is 6. X to the power 2 plus 3. All right. Okay, so that's the idea. Okay, so what about let's write f of x this time. We could write y, but it doesn't matter. F of x, x to the power -2. Again, let's take the derivative of this. So f prime of x is equals to, okay, now again, using the power rule, now here, the n here is this -2. So we got to bring this -2 down here, right? And then x to the power, the new power we have is, well, this n minus 1, right? So n is -2 minus 1. So we get, let me just write here. So we get -2 x to the power -3. Okay. Similarly, let's say if we have, let's see if we have f of x is equals to 1 over x to the power 4. Okay. Okay, in this case, we have a fraction now. So we know that the power rule is, if you're taking the power rule, it should be n times x to the power n. We can only use this power rule if we have y is equals to x to the power n. Here we don't have any fraction, but here we have a fraction. But we can get rid of this fraction, right? So we can get rid of this fraction using the algebra. So what we can do is basically just move this x to the power 4 to numerator or to the top. So that will make x to the power -4, right? So this +4 will be -4 when you move this to the numerator, right? That's algebra. So now, after that, when you take the derivative of this f prime of x, then we get, okay, now it's similar conditions, similar to this. So all we have to do is just bring this 4 down here, x to the power 4 minus 1. So this will be -4, x to the power -5. Okay, so we can leave our answer here. But if you want to do one extra step, you can even do, okay, you can even move this x to the power 5 back to denominator like this we have in the problem. So 4 over, when you move this back to the denominator, this negative power will be positive, right? So x to the power +5. So this is f prime. Okay, so these are a few examples. The power rule, basically, yeah, these are basically focused on power rules. Now let me introduce another thing, product rule. Okay, this video might be a little bit long compared to other videos, right? Because the other videos were basically 35 minutes, or one video was 45 minutes. But this video, I don't know, this video might be a little bit longer than that. I'm not sure. Let's see how long it's going to be. But it will be definitely less than our regular class time schedule, all right? I don't think it will be that much, because our regular class time is 1 hour 20 minutes, but I don't think it will be that much. But anyway, okay, so product rule, let's say h of x and g of x are given. Basically, what I'm trying to say here is, let's say f of x is equals to h of x times g of x. So you have some equation here multiplied another equation. So in this case, when you're taking the derivative, or something like this, then it will be, okay, so here these two are multiplied. So first we can just take the derivative of one equation. So let's take the derivative of this one. So h prime of x, then when you take the derivative of this, then times another equation will be the same. Plus, now in the second one, this first one will stay the same, and then take the derivative of the second equation, g prime of x. Okay, so that's the formula, or this is the product rule. So let's say, let's do an example. Ex, let's say example. So the example is, let's say f of x is equals to, let's say 2x squared times 4x to the power 3. Okay, so let's say in the exam, if I say find the derivative of this using product rule, then, well, you could simply, in this case, you could just multiply these two, right? 4 times 2 is 8, and x squared times x to the power 3 is x to the power 5, and then you can take the derivative. But let's use product rule here, okay? So here, when we say this, then we can say this is h of x, right? Because f of x is equals to h of x times g of x. Then let's assume this is h of x. This one is g of x. All right, then we can simply use this product rule. So using the product rule, well, first we can take the derivative of one of this. Let's just take the derivative like I did here. Let's just take the derivative of 2x squared. So when you take the derivative of 2x squared, it will stay the same. And x squared, the derivative of x squared will be, we can bring 2 down here, and x to the power 2 minus 1 is just x, right? Times the second equation will stay the same. The second equation we have here is 4x to the power 3, right? Plus. Now the first equation will stay the same. So the first equation we have here is 2x squared, and then take the derivative of second equation. So the derivative of the second equation would be, okay, again, 4 will stay the same. Bring this 3 down here. Then it will be x to the power 3 minus 1 is 2, right? Okay, now let's just combine this. So here 2 times 2 is 4, times 4 is 16. 16. X times x to the power 3 is x to the power 4, plus 4 times 2 is 8. 8 times 3 is 24. X squared times x squared is x to the power 4, right? Because when you're multiplying something like this, x squared times x squared means it's x to the power 4, right? Because if we have same base, then we can combine this to a single base and just add the power, right? So now again, now after this, now we have a plus, and we have a similar, basically we can say these two are like terms, right? Because we have x to the power 4, x to the power 4. That means we can just combine this. 16 plus 24 is 40. So 40 x to the power 4, right? So that's the final answer. Or let's say if we're taking the derivative of, let's say, e to the power x times x to the power 6. Then when you're taking the derivative of this, make sure you write this sign, all right? Make sure you write this derivative. Don't just write equal after, because I see some students just, from this, they just write equal and then they take the derivative. That's wrong, because that means you're saying that these two are equal, but you have to specify that, okay, you are taking the derivative of this function, and then write the answer here. All right, so again, when you're taking the derivative, okay, there is a multiplication sign here. So first, I can take the derivative of e to the power x. So like I said before, the derivative of e to the power x will stay the same, right? So e to the power x times, okay, so we took the derivative of e to the power x, which is e to the power x. The second equation stayed the same, plus Now, first equation will stay the same, and we're taking the derivative of x to the power 6, which will be 6. X to the power 6 minus 1 is x to the power 5. All right, so let's just arrange this answer. I don't know. Well, you can just leave it like this. Well, I don't think you can do anything. So yeah, that should be our answer. Okay. Okay, now let me do another one. Okay, that's cosine rule. Let me just write that. Another page. Let me just write everything single page. Okay, cosine rule. Okay, cosine rule says that, okay, if we have f of x is equals to h of x over g of x. So in that case, or in this case, now we have a division, or we have a fraction, right? So in this case, when you take the derivative of f of x, then okay, in this case now, here the idea is, okay, so here we take the derivative of numerator. Okay, this is a rule, so we take the derivative of numerator first, and the denominator minus. Now take the, okay, there will be minus here. Okay, now after that, take the derivative of denominator times just numerator. So first you're taking the derivative of numerator times the denominator will be the same, minus, now after that take the derivative of denominator times the numerator will be the same, over, one more thing, over, and then take the square of the denominator. Okay, so this is a rule. This is called quotient rule. All right, so now using this quotient rule, let's do an example. Let's do one or two examples. Okay, so let's say f of x is given, which is x squared over 1 plus x to the power 3. Okay, so now here using a quotient rule, all right, so using this quotient rule, f prime of x is equals to, okay, so first we have to take the derivative of numerator, right? So numerator times the denominator will be the same. So when you take the derivative of numerator, x squared will be 2 times x to the power 2 minus 1, which is just 1 on the power, right? So we don't have to write that, times the denominator, right? 1 plus x to the power 3 minus. Now take the derivative of denominator. So the derivative of denominator is, first you have to take the derivative of 1, which is 0. Well, we don't have to write that, it's a 0, right? And then the derivative of x to the power 3 is 3 times x to the power 3 minus 1 using the power rule, right? I'm just taking the derivative of this x to the power 3. So 3 minus 1 is just 2, right? Using the power rule. I just explained here. Where is it? Where is it? Yeah, this one. Okay, oops. Then after that, okay, and after that times just numerator, x to the power 2 over, now take the square of the denominator, so 1 plus x to the power 3 square. Okay, now after this, it looks like I can just distribute this 2x to these two terms, right? So then I get 2x plus 2x to the power 4 minus 3 times x squared times, so basically here we are multiplying, right? So in this case, x squared times x squared will be just simply x to the power 4 over 1 plus x to the power 3 square. So it looks like we have two like terms here. So this is equals to 2x plus 2x to the power 4 minus 3x is basically minus, right? So this is simply minus x to the power 4 over 1 plus x to the power 3 square. Okay, so this is how we can use quotient rule. Or let's do one more example. Let's say in this case, it says y is equals to 1 over x to the power 3 plus 2x plus 7. Okay, so now when you take the derivative of this, okay, like I said here, using the quotient rule, we have to take first we have to take the derivative of numerator. So when you take the derivative of numerator, we're taking the derivative of just 1. So when you're taking the derivative of just a number, it's 0, right? 0 times this whole thing. Minus, right? Minus. And then after that, now we can take the derivative of denominator. Numerator will stay the same. Now take the derivative of denominator, which is first, when you take the derivative of x to the power 3, it will be 3x squared, right? Okay, I'm just not explaining this anymore. I expect that you know it by now, because I've already explained this part. Now, again, when you take the derivative of 2x, it will be first just 2, right? And when you 2 will be there. And when you take the derivative of x, it is just 1, right? And when you take the derivative of 7, it's 0, so I don't have to write that. Okay, now over the square of that, right? Square of x to the power 3 plus 2x plus 7 square. Okay, now when you multiply this or 0 with this whole thing, so 0 times anything is basically just a 0. So this part will be just simply 0. So here, what we can do is just distribute this minus to these two. So from here, we can just write negative 3x squared minus 2 over this thing in the denominator, x to the power 3 plus 2x plus 7 square. Okay, so that's the final answer. Okay, so this is section 2.3. Now, but let me go to section 2.4. So 2.4 is basically the derivative of trig functions. I haven't talked about the trig functions yet. So, okay, from now on, I might introduce the trig thing somewhere. So once I introduce, so I'm going to introduce now. So the trig functions, I expect when you take a calculus, you know, basic thing about the trig, all right? But still, I will cover a little bit if we need in this class at some point, but right now we don't need to know too many things about trig. Maybe yes, a little bit. Derivative of trig functions. Okay, so okay, so when you're taking the derivative of trig function, then of course the trig means definitely the equation you will keep in mind would be the sine, cosine, tangent, right? So when we take, let's say, okay, so when we take, okay, first let's start with, we know, let's say f of x is equals to sine x, okay, and then we're taking the derivative of this. So when you take the derivative of this, f of x, or f prime of x would be, when you take the derivative of sine, it's cosine x. This is a formula, right? Similarly, let's say f of x is given. Now in this case, cosine x is given. And when you take the derivative of this cosine x, f prime of x, then it's, now when we take the sine derivative of sine, it's positive cosine x. But when you take the derivative of cosine, it's negative sine x. Okay, Similarly, let's say f of x is given. Tangent of x, then when you take the derivative of this, it will be secant square x. Okay, and df of x is equals to CSCR. I used to say this when I was in high school. I used to say this cosec. All right. F prime of x is negative cosec x times cotangent x. Oops. Okay. And f of x is equals to secant. Okay, now when I take the derivative of this, it's secant x times tangent x. Okay, and the last one is when you take the derivative of cotangent, then basically there is a way of getting this. So when you take the derivative of sine x, you get cosine x, but there is a way of getting this. In the book, it has shown you the way of or basically the proving uh, the derivative of sine x to cosine x. It has given in the book. If you want to read, you can read it. Basically, the idea is just using the definition of derivative. All right, but I'm not going to cover that. Okay, so if you want to, you can just read the book. But yeah, I'm just giving you for right now. I might cover that later on if it is necessary, but for right now, okay, I'm just giving you this, and using this, let's do some examples. Let's do, okay, I have 2 more examples, and then we'll be done for this lecture. All right. Okay, so let's say f of x is equals to x times cosine x. Okay, now this is given. Now let's find the derivative of this. So here, what we can do. So here, so we have x times, so basically one equation times another equation, right? So in this case, we can use product rule, right? So using the product rule, where is it? Where is it? Where is it? Okay, using the product rule, yeah, we can, basically we can just use this formula, right? So using that formula, I can say that, okay, let's take the derivative of this first one. So the derivative of x is simply 1 times the second one will be the same plus, okay, the first one will be the same, and take the derivative of now cosine. The derivative of the cosine is negative sign, right? So when I take the derivative of cosine, it's negative sign. Okay, then after this, cosine x, and then, okay, so this minus can bring this minus here, x times sine x. That's it. Okay. Next one. I think I need more space for this one, so I just want to show everything in a single page. So let's do another one. Next page. Let's say f of x is equals to cosine of x over 1 minus sine x. Okay, now let's take the derivative. All right, so when you take the derivative of this one, okay, so now here we have a division sign, so that means we need to use the product rule, right? So using the product rule, first we have to take the derivative of, oops, where is it, where is it, where is it? Yeah, we have to take the derivative of numerator first, times, then the denominator, minus, then take the derivative of the denominator. Yeah, just use this one. Yeah, so first let's take the derivative of numerator. So the derivative of numerator or cosine is negative sine x, and then this will be the same, the denominator will be the same, and then minus, right? Minus. Now the numerator will be the same now, and when you take the derivative of denominator, okay, well, then we have to take the derivative of 1 first. The derivative of 1 is 0, minus the derivative of sine is cosine, right? So minus derivative of sine is cosine, okay, over 1 minus sine x squared. Okay, now, okay, so here we need to distribute this negative sine x to these two, right? So then we get negative sine x times 1 is negative sine x. Negative sine x times negative sine x is positive sine square x. Okay, now here, this, well, basically here is a multiplication sign, right? So there is a minus here, and when you multiply these two, cosine x, that will be this minus and minus will give plus cosine square x, right? Cosine x is cosine square x, minus minus plus, over 1 minus sine x square. Okay, so one thing again from algebra, from trigonometry, sine square x plus cosine square x is what? Do you remember? Well, sine square x plus cosine square x is simply 1, right? That's basically a formula or a fact from trigonometry, from trig, all right? So now, so this will give just 1. So 1 minus sine x, right? I can just write 1 here, or 1 here, or 1 here, doesn't matter. So 1 minus sine x over 1 minus sine x square. And now we have 1 minus sine x on the top. We have 1 minus sine x squared on the top. So that means I can just simply cancel. Oops, I can simply just cancel this thing on the top and just 1, yes, because this will give sine minus 1 minus sine x times 1 minus sine x. So just cancel 1 terms from there. So it will be just 1 over 1 minus sine x, right? So that's the final answer. So that's the f prime of x. Okay, so that's all I want to talk for this lecture. I don't know how long this lecture became, but definitely I think it is this lecture is pretty long compared to other lectures. But anyway, like I said, this is not going to be, I'm not going to cover this section for exam 2. So this is not going to be part of exam. Sorry, this is not going to be part of exam 1, but this will be part of exam 2. All right. Okay, so study well for exam 1. I'll see you on the next video. Like I said, every time if you guys have any questions, email me. We can arrange time to see through Zoom. All right, so just email me anytime if you have any questions from anything, from homework, from the review. Okay. All right, see you on the next video. Thank you.